My name is Gaurav. I was just introduced to AIG few months back. Introduced means to the Bangalore chapter. So this was the initiative which the Bangalore chapter has taken. So I just thought to participate in it, and whatever effort or whatever support I can provide, at least I try to provide that. So in the brief, like currently I'm working as a lead consultant, and I have worked on Exadata from last 4 or 5 years. I'm working on Exadata majorly, and done a lot of benchmarkings on Exadata. Uh, so my core area is Oracle database administration. Um, so I think and let's start with the session. But so let's start the session. Okay, so let's go with the agenda. What the agenda of this session one is. Okay, so those who are not speaking, can they put their speaker on mute? Fine. Okay, so the agenda of today's session is, first we will just look into what exactly Exadata is. So we will just, I will talk about the Exadata. Then we will look into the Exadata machine X5 configurations. So X5 is the new machine which Oracle launched recently. So we'll look into the configuration of the Exadata X5. And then we will look into just the overview of Exadata storage server software, because we have, I think, kept one session specifically for Exadata storage server software and its key features. So here I will just talk about the overview of the key features of Exadata storage server software. And then I will give you an overview of Exadata architecture, its overall architecture. I think the second session, we will be covering even the in detail what Exadata and what internal Exadata is having. So we will discuss that in the second session. Here we will just touch upon the Exadata architecture. And last topic for today will be managing Exadata using AM12C. So I will be taking 1 hour to complete all this. So if you have any doubt or any questions, you can ask, you can raise a question, or you can send me. Suppose still you have any question or doubt which you want to check it later, you can send a mail to our group, and we can have. So let's start the session. So let's first we take a few years back. Right now we are in 2015. So let's talk about few years back, and how we used to, what is the traditional way of deploying a database for a ship. A few years back, what is the traditional way uh, of having having or buying a server or storage for Excite? What is the traditional way? So I just depicted in a diagram. So if you see the traditional deployment, so this is some kind of our traditional deployment. So your organization used to buy some database servers. They used to buy some storage if they have some one SAN or some SAN. So they can connect that with the database servers. And to connect that database server and storage server, they require some kind of network. It could be a 1 GB network, or it could be a 10 GB network. But if they are connecting using SAN, so it generally is 8 Gbps line to connect to your storage. This is the traditional way. That means you are buying database server from IBM, from HP, from Dell, from Sun. Okay, you are buying storage from EMC. You are buying storage from IBM. You are buying storage from Sun, and you are buying network from Cisco. So that typically we used to do. That was a traditional way. So what Oracle did is, so in around the year 2008, so what Oracle collaborated with HP, and what Oracle was trying to solve is the common bottleneck which we usually see in very large databases. So what is that problem? That problem is actually the inability to move sufficient large volumes of data from the disk storage system to the database servers. That is typically the major bottleneck for the large database. So as the size of the database begin to outstrip the ability to cache data effectively. Okay. Earlier we were talking about database size of 50 GB, 100 GB. If someone talk about a database, if someone talk about a database of size 500 GB, that used to be a huge size during 2007, 2008, right? But after that, now in today's scenario, if the database size is 1 terabyte or 2 terabyte or 5 terabyte, that seems to be a normal database size. So the typical problem was that the large volumes of data which travels from your storage to database server, that is actually taking a lot of time. So what Oracle did is Oracle in 2008, Oracle collaborated with HP and came across with the first Exadata machine that we used to call. Oracle began to look at ways to eliminate this bottleneck. Right, the bottleneck is between your disk and the database server. Right. So what Oracle came with a machine, right? Single machine. That is what we call the Exadata machine. So in that, what Oracle did is they combined the complete uh, set of infrastructure like your database server, your network, and your storage server into a single 42U rack machine, 42U rack. So in that you are getting everything which is required to create or to have database in your organization, whether it's a storage, whether it's a database server, whether it's a network. So everything Oracle combined in a single machine. So what is the advantage is very easy to deploy this kind of machine, and it has all the hardware required to run a database, Oracle database. So in this machine, your Exadata, in this Exadata machine, your database servers, your storage servers, and network are pre-configured, and pre-tuned, and pre-tested by Oracle. So it eliminates, actually, it totally eliminates the month of exercise which we generally put in tuning the complete infrastructure setup for running a database. And second advantage was, since this machine is unique, means whether a customer A is buying this machine or a customer B is buying this machine. So both machine configuration will be similar. Okay, that means if a customer is facing an issue and suppose there is a bug in that machine or software, so it can be very quickly, Oracle can provide the solution very quickly to the other customers as well, because since the machine is unique, there is no same kind of machine, same kind of infrastructure all the customers are using. So that is the advantage of this machine. Second thing is, like earlier when you are buying a database server from IBM, a storage from EMC, and network from Cisco. So we usually have seen these kind of scenarios where you are facing some performance problem, and database server used to point fingers at storage guy, and storage guy used to point a finger on, say, server admin guy, and server admin guy can point a finger to network team. And each one will be following their respective vendors to provide a solution or provide a solution to this problem. But in case of Exadata, since the complete machine is being shipped by Oracle itself, so there is a one point of contact only to get all your problems resolved. You have to raise an SR or only in Oracle for all kind of your problems, whether it's related to storage, whether it's related to database server, or whether it's related to network. So there is only one point of contact for any organization for any kind of issues in this complete setup. So then the question arises, then what is this Exadata? So people generally say that Exadata is a machine with a huge kind of storage. That is in one line, it's true. That has a huge storage. But that's not the only thing about Exadata. So Exadata is about hardware, it's about software, and the more and most important thing is about the integration of hardware and software. Earlier we used to buy hardware separately and software from Oracle to run the Oracle database. In Exadata we say that we are buying the hardware from Oracle, which is tested, which is tuned, which is optimized. Plus we are buying the software again from the Oracle, whether you are running Oracle RAC or you are running Oracle Database Enterprise Edition. So these softwares are also being provided by Oracle. And third important thing, which I think is very important, is the integration of the hardware and software. Okay, so for me, as I said, that the third point is more critical and more important for running a optimized database. Because hardware you can buy separately, right? Software also you can buy it separately. Only the third part, the software provider services or the normal DBA, or I can say the group of TBA, system admin, network admin, and storage admin was doing. So one of the component could be optimized, but you cannot say all the four components are optimized to run your Oracle database. So with the Exadata, what Oracle did is they provided the complete set of hardware and complete set of software, plus integrated it and tested it and tuned it and optimized it. So it's a full stack optimization, okay, and support to reduce operation cost. How it's going to reduce the operation cost? As I said that when you buy an Exadata, so Oracle comes to your center and configure this machine for you. That means your task starts from the uses of the database and configuring the database as per your requirement. So that means the efforts which you used to do, not only you means the system admin, database admin. So all these people used to sit together and try to tune the server, storage, network, all the components to run the database at the optimum level. But here that effort has been reduced, even has been eliminated totally. So that's why we are saying that it is support, that is, it is reducing your operation cost also. So let's start with the Exadata machine configuration. Okay. So there are two different Exadata X5 machines available. Not only in case of X5, if you have with your customers X3 or X4 or X2, all these machines have two different kind of configurations. And as I said earlier, that first Exadata machine came in year of 2008 and it's 2015. So it's not the new machine right now. It's the X5 machine is actually the sixth generation of the machine which Oracle is shipping right now. So when we say two different Exadata X5, so what does it mean? You must have heard people saying X52, X58, X42, X48. These terms you must have heard. So that's what we used to say in Oracle. Like there are two different Exadata X5 machines. So I tried to simplify it so that you all can understand what does it mean. So there is one machine which comes with two sockets. Two sockets means two sockets for your processor. So there is one machine which comes with two sockets per server, per database server, and there is one machine which comes with 8 sockets per server. So these two machines, that's why we say there are two different Exadata X5. There is a one machine which comes with two sockets each database server. Second machine, 8 sockets per database server. So when we talk about two socket machine, so Oracle termed this machine as Exadata X52 database server or Exadata X52. So your X5 is actually the version of machine and 2 is -2 is the socket, number of sockets. So now you can easily depict what could be the meaning of X32 and X42. So X32, if I say, so X3 is the version of the machine and 2 is the socket, number of socket in that machine on the database server. So similarly, your 8-socket machine, if you are talking about 8-socket machine, so this machine we used to say it's Exadata X58 database server. So Exadata X5 is again a version, and -8 means it's a 8-socket per database server. So all Exadata machine from the first generation to the 6th generation, whether it's X52 or X58, all comes with the Intel processor. Okay, so in the X52 machine, Oracle is right now using the latest Intel Haswell Xeon processor, and the configuration which is in your screen is the configuration of one database server only. Okay, so before moving forward, let me just explain what we have discussed this 2-socket and X52 database server. Let me just explain what is actually the Exadata. So in case of Exadata, what there actually is, so Oracle has bought some commodity servers and combined them and created a complete Exadata machine. So when I'm saying commodity servers, so there is one server, like one configuration is your X52, Exadata X52 database server. If you go to Oracle site, you will also get Oracle Server X52 as well. So what does it mean? Are both machines same? No. Exadata X52 database server, when we are talking about, you can simply say that it's actually a combination, or you can say is having a multiple X52 servers, Oracle X52 servers. So that means in this machine you are not getting a single server or single storage, you are getting multiple database servers, multiple storage servers. So when we are saying storage servers, so you don't think it like a SAN. You can think it like a server, single server with huge amount of storage space. So Oracle has combined, say, 14 storage servers, like 14 such commodity servers, and created a storage, big storage. And in a full rack, Oracle has combined 8 such commodity servers and created a rack of database servers. Okay, so this configuration, when I'm talking about one server, and specifically I'm talking about a database server. Okay, so each database server is having a 218 core Intel processor. So that means in one machine you are getting 36 cores in one database server only. And you get 256 GB of RAM, which you can extend up to 768 GB. You get 1 GB port plus 10 GB ports, both in the Exadata machine. In case of your data center is having 1 GB, you can connect that to the Exadata. In case you have 10 GB connectivity in your data center, you can connect that to into the Exadata. Plus you get a dual port InfiniBand port as well. So why dual? Because I will explain all in detail. And then you get some amount of space in the database server. So this space is not where we are going to create our database. This space is actually where we are going to install our softwares only. We are not going to create our database on this storage. So this storage space is only for in a database server we are talking about. So I'm just repeating it again. Right now when I'm talking about this configuration, this is only about a database server. And then this controller and redundant power supply, of course. Same way when I'm talking about a 8-socket machine, that is the Exadata X58 database server. So it comes with 18 core again, but it has 8 such sockets. So 8 into 18, that much number of processors you are getting in only one machine. plus you are getting a 2 terabyte of memory in one database server only. Plus again same 1 GB port and 10 GB port, and plus some space to install your Oracle software, plus redundant power supply and disk controller. So I think by now you should be clear that what does X52 means and what is the meaning of X58. So anyone, if anyone asks you what is the meaning of X52 and X58, you can simply say X5 is the version and 2 is the number of socket. Same way X58 machine, X5 is the version and 8 is the number of sockets. So this is the latest Exadata configuration. So this is only about the database server. Now let's move to the storage server. So as I said earlier, that Exadata machine is a combination of your database server, your storage server, and the network. All three things combined in a 42U rack. So just before this slide, we have seen the database server configuration. Now we are going to see the storage server configuration. And as I said earlier, the storage server is again in a full rack. If you talk about it, again you can say that it has a multiple number of storage servers. So right now when we will be talking about the configuration, that configuration will be of only one storage server. So as we have seen that database servers, we have two different types of machine with 2 socket machine and 8 socket machine. So in storage server also we have two different configurations. One we call a high capacity machine. You must have heard this term. One is called a high capacity and another we call extreme flash. So your extreme flash actually starts X5 version. Before that we used to call a high capacity and high performance machine. So these two are different storage configurations in your Exadata X5. So either you buy a high capacity machine or you buy an extreme flash machine. Okay, so either you, in case of a storage server configuration, it will be either be a high capacity or it could either be an extreme flash. So when you are initially buying a machine, Exadata X5 machine, so you could order either a high capacity or an extreme flash. But after that, if you want to have a combination of high capacity and high extreme flash, you can do that. That means suppose today you bought a machine, X5 machine, and after that some time you want to increase the storage capacity and you want to have a extreme flash configuration. Also you want to have a storage with extreme flash. So you can do that. So that is the storage server configuration. So again, if you see that high capacity, it's again has 2 8-core Intel processor. That means 16 core per server. And why the 16 core is required? That is again an interesting question, right? Why the 16 core is required in a storage? And that 16 core is per server. So that we will discuss when we will be discussing key features as well when we will be discussing our last topic, that is the key features of Exadata. So that is the important point. You all should note that the storage comes with a core, number of processors. Second important thing which the storage server comes with is the flash. Okay. So each Exadata storage server comes with 4 flash PCI cards, each with 1.6 terabyte of capacity. That means when we are talking about one storage server only, one storage server does not mean the complete storage of Exadata. One storage server means only one of the commodity server which I am talking about. So one storage server comes with 6.4 terabyte of flash only, and it comes with 12 disks. So each server will have 12 disks each, and one disk is of 8 terabyte. So that means you are getting around 96 terabyte raw capacity per storage server. I'm again repeating per storage server because it's not the capacity of complete Exadata. It's a one storage server capacity. So one storage server coming with 16 cores, one storage server coming with 6.4 terabyte of flash, and one storage server coming with 96 terabyte of raw capacity. And again the dual port InfiniBand and the disk controller and the redundant power supplies. Now when we are talking about extreme flash, the number of processors are still same. It's a 16 core machine. But the important thing what Oracle did with X5 is, and in case of extreme flash, they have removed the disk. Now they are coming only with the flash drives. So in extreme flash, you will not get a disk, you are getting only flash drives. And each server you are getting 8 flash drives and each 1.6 terabyte of capacity. That means in one storage server, you are getting around 12.8 terabyte of storage in one storage server only. And this flash are hot swappable. And it works similarly like your disk, but it's the fastest way of retrieving any data. So if you compare these two machines, your high capacity and extreme flash, so what is the major difference? The major difference is in high capacity you are getting disk to store your data of your database, while in extreme flash you are getting flash only to store your database, to store the data or the table space and data files of your database. So this is the major change which Oracle did from X5 onwards. That means in extreme flash, all your database files will be on flash only. Now let's just talk about Exadata configurations. Till now you know what is X52 and what is X58. You also know that the storage configurations. You know that you will get a high capacity machine or an extreme flash machine. Now let's just talk about what is the configuration, like Exadata, different kind of Exadata configurations. So Oracle Exadata comes with a full rack machine. Full rack means complete 42U rack. Whether you buy a full rack or any other configuration, you will get 42U rack. Inside that, you will get different number of servers. And that depends what kind of configuration you are buying. So Oracle Exadata machine, first configuration is a full rack machine, then half rack, and then quarter rack, and then 8th rack. So 8th rack Oracle started with X4. Before that you used to get till only quarter rack. So this is 4 different configurations. So now with X5, what Oracle has done is, the latest thing is that you can have your own configurations also. So what does it mean, my own configuration? So my own configuration is, today suppose you buy a quarter rack machine. So okay, look, let's first look in detail. What does it full and half and quarter and 1/3 mean? So if you see this, the numbers, if you see the database server, storage server, InfiniBand, switch, flash, and storage capacity, and full, half, quarter, and 1/8. So I created just to briefly explain you, like, but just by seeing your number, you can understand what does these configurations mean. So when I'm talking about a full rack machine, so you can see that full rack comes with 8 database servers. If you remember, in the database slide, we discussed one server configuration only. And that means in a full rack, you will get 8 such machines. And you will get 14 storage servers. And in last slide, we discussed only about one storage server. That means you will get around 14 such storage servers. and you will get, of course, 2 InfiniBand. And in half rack, you get 4 database servers, 7 storage servers, and InfiniBand in all the machines is 2 only. In the quarter rack, you get 2 database servers, again 3 storage server, and in 1/8 again you get 2 database server and 3 storage servers. So you can see that the configuration, that is the number of database and storage server in quarter rack and 1/8 rack, is same. 2 database servers and 3 storage servers. So then what is the difference between a quarter rack and 1/8 rack? So the only difference between a quarter rack and 1/8 rack, if you see the flash and storage capacity size, it's half. That means in the 1/8 rack machine, the hardware you will get is similar as of the quarter rack machine, because Oracle does not ship any machine which is having less than 2 database server and 3 storage servers. So that means the hardware you will get same. But the only thing is, in the database server, your half of the number of cores will be disabled. That means if you are getting 36 core per database server in quarter rack in one of the database server, in 1/8 rack you will get only 18 by default enabled. Similarly, in storage server, you will get half of the disk disabled. That means in each storage server you have 12 disks. That means only 6 disks will be enabled in 1/8 rack machine. Similarly, in case of extreme flash, half of your flash will be disabled. That means the difference between a 1/8 rack is, hardware wise there is no difference. You will get similar hardware in case of quarter and 1/8. Only difference is your half cores in database server is disabled, half number of disk and flash in the storage is disabled. So what I was saying earlier, now suppose you buy a quarter rack machine, right? So you get 2 database server and 3 storage server. In earlier till X4, what was the restriction? That I can buy a quarter rack and I can, if I want to upgrade, I can upgrade it to half rack machine. Or if I am buying a half rack machine, I can upgrade it to only full rack machine. There is no in between half and full. That means if you are buying a half rack machine, that means 4 database servers will be there and 7 storage servers will be there. So you have to order, okay, from half rack also you can add additional quarter rack as well. That means you have to buy 2 database servers and 3 storage servers. But suppose if my requirement is not to increase storage servers, not to increase 2 database servers, I want only 1 database server, that's it. So is it possible till X4? The answer was no, you cannot do it. But from X5 onwards, Oracle is more flexible in terms of adding the number of database servers as well as adding the number of storage servers. That means now you can add as many database servers you want as well as many storage servers you want. If you want to increase only a database server, you can increase a database server. If you want to increase only a storage server, you can increase only a storage server. So there is no such restriction to buy the database server and storage server of the quarter rack or half rack or full rack configuration. The only restriction is initially you have to buy minimum 2 database server and 3 storage servers. That means it should be a quarter rack or 1/8 rack kind of configuration. Then only you can add as many database servers you want, or as many storage servers you want, or as many Exadata machine you want to connect. So X5 elastic configurations, that's what I just discussed, that this is what we call a elastic configuration, that you start with the 2 database server and 3 storage server, which is still a restriction that you have to have this kind of configuration before adding any number of database servers or storage server. So after that, you can add server any kind and any quantity. That means if you want to add a database server, you can add it. If you want to add 1 database server or 2 database server or 3 database server, there is no such restrictions. Okay, of course, this is a 42 rack machine, you cannot go beyond it, right? But apart from that, there is no such restrictions. and there are 3 storage servers. After that, if you want to add say 2 storage servers only, you can add it. So that means now you can prepare your own in-memory kind of machine where you can have multiple database servers and where you want to have the database data in memory and you need lesser storage amount. Or you can have a complete, say, OLTP kind of machine you can create, Extreme Flash, right, where you buy the complete flash, Extreme Flash storage, okay, and you can prepare your own data warehouse kind of machine where you need more storage than the database number servers. So you can add as many storage servers in this machine. So from X5, what I want to say is it's elastic configuration. Of course, there is one restriction that you have to start with at least 2 database server and 3 storage server. After that, you can add as many database server or a storage server as you want, and you can prepare your own machine afterwards. Now, Oracle also came with this Exadata cloud service. You might have heard about this term, the Exadata cloud service. So, like you buy a Exadata in your environment, you can have, you take this feature that Oracle Exadata cloud service from Oracle also. The advantage which you get is you get the same Exadata which you are getting in your on-premise environment. You will get the complete Exadata machine itself. The advantage is you don't have to procure a new machine for you. You can save 1 or 2 months of shipment time, what Oracle takes generally to ship machine from US to India or whatever region you want. So you can start it very quickly. If suppose you want to start from tomorrow, your application you want to deploy on Exadata, you can take this cloud service. Okay, so the only thing is that you will get the same Exadata machine what you are getting in on-premise. The only advantage which I see is you don't have to wait for Exadata to be land in your data center. Then you will take 1 or 2 more months to migrate your database into your Exadata. Then only you can start your operations. But in case of Oracle Exadata Cloud Service, the services are ready. You just have to use it. It's a pay-per-use model. That means you want to pay. How much you want to use. You just pay for that model, and you can go start using with the Exadata. And second, of course, the advantages for the organization is that they don't have to cover a lot of money. The one-time payment they can save, like the full rack Exadata. If I say that the list price in the Oracle side is around 1 million for the full rack, that means you can save the one-time investment on the hardware upfront. You can directly use the Oracle Exadata Cloud Services instead of buying Exadata in your premise. This is the configurations. If you have any question or doubt, you can ask, or let's start with, or we can continue with the key features. Okay. So let's start with the key features. Okay. So when we are talking about Exadata, so people generally talk about the hardware of Exadata. They say that it's have so much size to store the data, so many number of cores, so much terabyte of flash, InfiniBand switch, 40 GB per second speed. Okay, that's all okay, right? But as I said earlier, that this is the commoditized that Oracle has clubbed together to prepare this Exadata machine. So is Exadata really about the hardware what Oracle providing? The answer is no. Is it about the software what Oracle is providing? The answer is again no. As I said in my first slide, that this is not about hardware. It's not about software. It's about the integration. Okay. So as I said earlier also, that if you go to Oracle site and you type Oracle Server X52, you will get a single, that 1U rack machine, 1U rack server. If you type X58 server, you will get a X58 server listing in Oracle site. You can buy that single machine itself. You can buy an InfiniBand switch. You can buy the X528 2L server which is used in the storage. You can buy all this machine, you can buy this empty 42U rack, and you can build your own Exadata. Okay, but the answer is no, you cannot build it like that. You cannot combine this hardwares and start using it as your own Exadata machine. Because Exadata is not about the hardware what Oracle ships in this 42 rack machine. It's not about the Oracle database software also, because you can buy Oracle, you are running or you are using the Oracle database software from so many years. It's about one unique thing in Exadata that we are talking about is a software which is there in the storage. So in Exadata we say that the storage is not dumb. By dumb what I mean is, if you talk about any storage right now in industry and you are running your database on top of that storage and you execute any query. So in general term, when you execute a query, if you are executing a query on say table A, and table A is say 1000 block size table, the storage does not know about what the table means. Storage does not know about the index. Storage does not know about the partition. What it knows is that I got this starting address and I got this end address. I just have to pass this data between these addresses to the database server, to the server who has requested this data. So storage used to ship all this data in the 1 GB line or say 10 GB line in your data center to the database server. And in database server, Oracle database has to store the data into the cache, that is as your buffer cache in the database server. So that is what generally happening in the traditional way of using a database. In case of Exadata, what we are saying is, what Oracle says is that the storage is not dumb. When we say the storage is not dumb, what does it mean? If you remember that I discussed about the number of cores in the storage, that is around 16 core per storage server. If you multiply it with the 14 storage servers, you will get around 168 some number of cores in the storage server only. So why so many number of cores are required in storage? That is because there is a key feature, that is what we say is a unique software which resides at the storage server side, which we used to call Exadata storage server software. So that is the additional software which gets shipped along with the Exadata. That means in Exadata you are not only using your Oracle database software and rack software, but also you are using one more additional software, that is the Exadata storage server software, which is not at the database server side, which is at the storage server side. That means the software is residing at storage server side, and this software is actually making this Exadata machine unique than any other machine. This is the software because of which you are getting, if you have used this machine in any of your client environment or customer environment, you must have seen a lot of performance improvement. And because of this software, you are getting that much performance improvement. And without this software, this is any other machine as you have in your data center right now. So this is the unique software which Oracle Exadata is having, because of what? Because of that you are getting a lot of performance improvement. So when we are talking about, when we say that, let's discuss about the Exadata key features. So here Exadata does not mean the Exadata hardware we are rather talking about the Exadata storage server software. So this unique software optimizes database processing. So what this software does in storage is, in Exadata, that's what we say, that you get a offloading, which is the major feature of Exadata, and this is the, I will say, a unique feature in Exadata. So we will look into about, we will see what offloading is, but just to give you a brief about it, that in offloading case, your Oracle software is actually shipping, or we say in Exadata terms of function shipping, that means ships some of the operations to storage. That means your storage does some of the operations when in traditional database server, your database server is supposed to do. That means you are reducing the amount of work the database server is right now doing, and you are offloading that task and offloading that part of the operation to storage. Second unique feature is your hybrid columnar compression. And this compression feature is again unique to Exadata. You also get this compression feature is one of the Oracle storage also, but it is still unique in Exadata. You don't get this benefit in any other Oracle software running on any other hardware or any other storage. So this feature you specifically get in Exadata, where Oracle says that you get around 10 times of database size reduction. And I have seen during my benchmarking time that people have got even more than 20 times also. But Oracle generally says it is 10 times, and it totally actually depends on your data which is stored in your database server and in your database. The more common type of data you are using, the more compression you will get. But this is actually something new which Oracle did with the compression, because Oracle also come with the Oracle compression. There's a different software, this different license product from Oracle, advanced compression. So that is different, and this compression feature is totally different. You still can use that compression feature in Exadata, but Exadata hybrid columnar compression is actually more into the storage part, not from the database server part. And third important part is the smart flash cache. So if you have seen any Oracle slide about Exadata or any PDF about Oracle Exadata, you don't see that they generally term is flash cache only. And they used to say it a smart flash cache. Why it's a smart flash cache? Because Exadata storage server knows that what kind of data the database server is requesting, and it stores only the data which is going to be frequently used, not like any other flash drives or flash which used to generally store all data which is being requested to it. Third is your high availability, of course, because there is no single point of failure in the complete machine. If you remember, I said that Oracle does not ship any machine with less than the 2 number of database servers and 3 storage servers, just to maintain the high redundancy and high availability of this machine. So from the power, that means from the power also Oracle supplies 2 PDUs minimum till your database instance. Okay, so from the power to the database instance, everything is high available. There is no single point of failure in complete machine. You can remove one disk from your storage. You can remove one complete storage server from your Exadata machine. You can remove your complete database server from your Exadata machine. Of course, you should not go in your customer environment and try. Okay, that is already tested. Okay, and that's what we say, that this is a high available machine. And you just assume that if you have to configure this kind of machine in your environment, how much effort you are going to put to prepare this kind of machine itself, hardware itself. And last thing is like your Exadata database. This is database optimized network, because if you remember that I said this Exadata, mainly it's a 3. You can divide the complete machine, this 42 you rack, into 3 main parts. So what Oracle did with Exadata is they have made the pipe bigger. Pipe, in terms of pipe, I mean to say the network. Instead of using a 1 GB or 10 GB network line, they have used a 40 Gbps line. That means they have increased the pipe size. That means more data will flow from your database server and storage server to database server. Second thing what Oracle did is they reduced the size of data which get transferred from storage to database server. How they did it? Because of the Exadata storage server software, because of offloading and smart scan, and of course storage index. So they reduced this, they worked on these two major bottlenecks, that is the pipe of the size of the network, and second is the amount of data which actually gets transferred from your storage to database. So this is offloading is actually, we used to say this is the major, say, performance enabler in Exadata. It actually reduces the amount of data which get transferred or which get shipped from your storage to database server. As I said earlier, there are many operations which Oracle is trying to push on storage right now. So if you want to see the complete list, you can log in your database and you can fire a query on $SQL fn underscore metadata. Over there, you will get the complete list of all the operations which in Oracle Exadata, Oracle database can ship it to the storage. That means more and more operations in Oracle database is actually happening at the storage server side, which means if suppose you are firing a query on 100 GB table and you actually need 50 GB of data only, so this storage is actually returning you only 50 GB of data instead of returning the complete 100 GB of data. So this is a major improvement, and I will say that this is the major advantage, this is the major feature through which you are getting such performance improvement in Exadata. So this is a traditional way of your query execution. In normal case, you fire a query on a table. Okay, suppose this is your query. Your table extent actually gets identified from where? From the metadata which is there in your database, and then an IO is issued that this is my starting block address, this is my end block address, I want all this data. Since this storage cannot perform any operation on this data because it does not understand what this customer name, what does calls means, what is the where clause meaning, what is amount greater than 200. It does not understand all these things. So what it does is, okay, I got this minimum block number and maximum block number. I have to send the complete data back to the database server, and then it executes the IO operation and sends all the data back to the database server. What happens? Your SJ gets filled from this data, and then database server is going to perform some operation on the data and going to return data back to the application or the user. This is the traditional query processing. Now in case of Exadata, because of offloading and smart scan, what happens is you are executing the same query. Similar operation will happen again. It will identify the extent and metadata from the metadata stored in the database, and then it sends the request back to the storage. But here in Exadata we say the storage is not dumb, it's smart. So what it does is it identifies this where clause, it identifies the column name, it identifies the table. So it executes and tries to do some operation there in the storage itself and trying to return only the required data. In earlier case it is around 1 terabyte, now it is running on a 2 MB of data back to the database servers. That means database server now have to perform very little amount of operation on the data which is returned from the storage. So what is the advantage of it? The advantage is your CPU cycle in the database server is idle. That means right now suppose your database server is 70% consumed, and in Exadata when we have the same database size, same operations we are doing, it will be reduced by say 30% or 40%. Why? Because in Exadata, most of the operations, I will not say all the operations, but still most of the operations get executed at the storage server level only. And the storage is processing all those data and sending data back. That means what I said is Oracle attacked on two major problems. One is the amount of data which gets shipped from storage to database server. And second, I said that increase the pipe. That means now the storage server is returning less amount of data using bigger pipe. Earlier you were returning 1 terabyte using a smaller pipe. Now Oracle in Exadata is returning lesser amount of data using bigger pipe. That means because of this your performance is actually improving. This is a smart scan what just we talked about. That means it returns only the required number of rows and required number of columns back to the database server. It does not return all the data which is even not required by the query. It does not return all the data. It returns only the relevant data back to the database server. So this is just the overview we are giving. We will discuss it in detail in the, I think, the last session. And then the storage index again is the combination of your we see it in a combination of your offloading and smart scan feature. If you see, I mentioned it is anti-index because it actually tries to eliminate the number of blocks which is not required by the operation or which is not required by the database server. So what it does is, if suppose this is your table where you are storing the data. So in case of storage index, it tries to store minimum and maximum value for 1 MB of region, not for the complete table, for only 1 MB. Suppose this is a 2 MB table. 3 rows consist of 1 MB region. So for 1 MB it is storing minimum value and maximum value. So in case of here, it is the minimum value of 1 and maximum value of 5. In the second 1 MB region, the minimum value of 3 and maximum value of 8. This way what we are creating the indexes, we call actually a region index. Why it is a region index? Because this is for 1 MB, every 1 MB region there will be such indexes, and this 1 MB is not going to affect this 1 MB of data. Okay. So if suppose you see this query where b is equal to 1, if suppose I am executing this query just to see how it is improving the performance. So if b is equal to 1, first time there is no benefit of a storage index. Why? Because first time when you run the query, actually Oracle creates in Exadata creates these region indexes. So when you are running a query first time, you will not get any benefit, but the second time onwards you will get this benefit. So if suppose when I executed this query first time, so this region indexes will be created with minimum and maximum value for every 1 MB of region. But when I'm running this query again second time, so what now it does is it goes and sees, okay, there is a region index for this column B where I've executed this condition, put this condition. So it goes there and check, okay, this is my condition where B is equal to 1. And it tries to see the minimum and maximum value. So minimum B is equal to 1, maximum B is equal to 1. Okay, that means I will get this B is equal to 1 in this 1 MB range. That means this block is required for my query processing. It goes to the next block and see again, it will not read all the rows in that 1 MB. Instead of that, it just reads this minimum and maximum. So right now it goes there and sees, okay, this B value minimum is 3 and maximum is 8. That means this block is not going to get any, this block is not having this B is equal to 1, that means 1 data in B column. That means even if I read this block is not having the required data. That means there is no need to read this 1 MB of block. What does it mean? That in this 2 MB table, here Oracle is only in Exadata is only reading this 1 MB of region. It's not reading, it's completely eliminating the second MB of region. It is not reading this complete rows, all these blocks. So in that way, Oracle reads only the required number of blocks where the actual data is, and then sends back to the database server instead of sending all the blocks to the database server. Then there is a Exadata hybrid columnar compression feature. So in the compression feature, columnar compression feature, Oracle tries to store the data in the columnar way and then tries to compress it. So generally, this is actually a Exadata specific feature, and we have generally in there are two modes in Exadata hybrid columnar compression. One we call query mode, another we call archival mode. How we do it and what is in detail, we will discuss it, right? It's not right now we are discussing it. Right now we are just focusing on overview of this feature so that we can discuss it later. So there are two major modes, that is the query mode and archive mode. So query mode, what does it mean? Query mode means even if you are compressing the data. So first of all, let me tell you that you should not use the hybrid columnar compression when you are performing a lot of DML operations on the data. You should avoid using columnar compression. So that means you should use this columnar compression only when you are selecting the data from the table majorly. So 95 or 90% you are selecting, only 5-10% you are doing some DML. But if you are doing say 10% of DML, 20% of DML operations, even more, you should not use columnar compression. But in case if you are executing majorly, most of the time you are executing queries on the data. Just for example, if I say that in your database, suppose you are having say 15 days partition in your table. Okay, so generally historical partitions we don't execute on historical partitions. We don't execute your DML operations. We generally keep them for any regulatory compliance purpose or any SLA purpose, and we generally sometimes fire queries on those partitions or on those data as well. So for this kind of data where you are executing some queries also, Oracle recommend to use the query mode of the columnar compression feature. In case if you are using it just to store the data for historical purpose, that means you want, if suppose as per the regulatory compliance, if you have to store 2 years of data in your database, and if you are executing queries on data, say last 2 months of data you are executing queries, but before that you are not even executing queries as well. So you can use the archival mode of columnar compression in the partitions which are older than 2 months. Till last month you can use the query mode compression, and for today's data you don't use any compression. That means in a single table you can have multiple compression features available. You can apply multiple compression. You can use the advanced compression, you can use your query mode compression or columnar compression, you can use archival compression, or you can use even a single table as well, depending on the nature of the data as per the uses of the data. Then there is the IORM feature, that is the input output resource management feature. So Exadata we generally don't buy for having only one database, right? We buy it for some consolidation purpose. You want to have multiple databases running on Exadata machine. You are running your OLTP plus data warehouse, both kind of environment in one Exadata machine. You might be running your test and your production database in one Exadata machine. You might be running your SAP databases on one Exadata machine plus some other critical databases on one Exadata machine. But the resource in terms of storage is same, one. Is a one, that means when you buy Exadata and you start using it, so in storage servers, you have the only option of using ASM to create your disk groups, and then on top of it you create your table spaces, which we'll see in second session. So when you are having one ASM only on all the storage server and your multiple databases are using that ASM instance, so there is no way to restrict the IO. Okay, so in Exadata you have a feature which we call IORM, Input Output Resource Manager. It is actually the extension of DBRM, that is a Database Resource Manager feature, which is there I think from 8i or 9i. But IORM uses this feature and tries to segregate the IO resources as per the requirement or as per the criticality of the database. Suppose you are running say one very critical database on Exadata and one say lesser critical amount of critical data on Exadata. So you can divide the IO resources between these two databases so that your non-critical database should not consume all the IO resources, and your critical database is having lesser IO resources available. That means you are getting performance issues on your database. So we'll discuss this in detail also. So this is the architecture of your Exadata storage, Exadata. So here you have the database servers. Over there you are using your database instances and your ASM instances, and you have the storage server. You are in the storage server. You have only one option of using Oracle Enterprise Linux only. In database server, you have still option of using Linux and Solaris, but in Exadata storage, you have only one option of using Oracle Enterprise Linux. And in Oracle Enterprise Linux, there are multiple processes like cell SRV. So cell SRV is the main critical process in the storage server. Even you can say the Exadata storage server software, which we just talked about, is actually this cell SRV process. So this cell SRV process is responsible for complete your offloading, your flash, and your IORM, all these things being done by your cell SRV process only. Your MS process is actually management server process, which is being used to manage your Exadata machine, Exadata storage. And the RS process is the restart server process. Its role is to just sell SRV and MS process, and if it finds any of the processes down, it just restart that process. So major critical, these are the three major processes in your storage, and the cell SRV is the main software and main.
Gaurav, Gaurav,
Yeah.
Sumit here. So, like it's 4:12 now.
Okay, so I will complete in next 5 minutes.
Okay, fine. And then we may need to take questions. I see few chats here. So, Arun, you have few questions, right, already?
I have just got one over here, so let Gaurav finish. I'll pass it on.
Okay, fine. Over to you, Gaurav.
Okay. Thanks, Sumit. And in between, you find this InfiniBand network. That is, this is the network which is being used for the communication between your database server and the storage server. And how to manage this database server and storage server? You can use your Enterprise Manager 12c. You can use it. And to manage your storage server, you can again use your Enterprise Manager. Plus, there are two more utilities in Exadata storage that we call cell CLI and DCLI. That is the cell control utility in the storage server only, not in the database server. So for managing your database server and storage, you either can use the Enterprise Manager can manage your database server, InfiniBand switch, and your storage server. But to manage your storage server, you can also use the cell CLI, which you can use to manage the storage server as well. So Exadata monitoring, as I said that for a storage server you have cell CLI and DCLI. There are two different utilities. This is the command line utilities you can use in your storage server. The only difference between these two utilities are cell CLI is a local utility. Local utility means if you have 14 storage servers and you want to check say date of or you want to do some operation on one storage server or say 14 storage server, and if you are using cell CLI, so you have to go and log in each and every storage server to perform that operation. So that's why it is a local utility. That means it will, the effect of this operation will be only in that storage server. While DCLI is a distributed utility, cell CLI utility, it internally executes the cell CLI only. But the advantage of this utility is it can, in a single point of time, you can run multiple commands. You can run same command on multiple storage servers. So this is the advantage of having DCLI. And of course, our favorite EM12C. You can use EM12C to manage your database. Your storage servers managed from your from EM12C. So from the storage, all your cell homepage, performance page for the storage server, everything you can see in the EM12C only. You can manage your InfiniBand switch. You want to check what is the performance issues, how many ports are utilized, how many ports are not utilized. If you want to get any information, any alerts, any metrics you want to monitor, you can monitor it on EM12C. And of course, you have ILOM. You can monitor it using ILOM as well. That's all from my side. If you have any questions, so we can discuss it right now. And these are the two sessions where again our pipeline. I think we have this information as well with you.
Thank you,
Well,
Gaurav. Over to Arun. I think you can take over and pass it on the question, and Gaurav can answer that.
yeah, sure. Thanks, Sunil. So, first of all, I would like to thank Gaurav for this fantastic introductory session on Exadata. It was quite knowledgeable, and I believe it has covered quite touched upon a lot of topics which people actually wanted to know and the kind of doubts that they have on Exadata. So, Gaurav, I have a question from Harihar who wants to know that if you can let us know something about the Exadata shutdown and the startup sequence.
Okay. So shutdown means like if you want to shut down Exadata, you have to start with the database first. If you want to shut down the complete Exadata machine, if I assume you have to shut down the complete Exadata machine, you have to start with the database. You have to first shut down your database, then your ASM, then your clusterware, then only you go ahead down your storage. You should not go directly to the storage server and shut down your storage first, then you go to the database server. So this is the sequence of shutting down the complete Exadata machine. First shut down your database, then shut down your ASM, shut down your clusterware, then shut down your database servers, then move ahead and shut down your storage server. In case of a startup, just the reverse of this shutdown operation. You will first start your storage servers, then you will start your database servers, then you will start your clusterware services. I think that actually get automatically started. Then you have to start your ASM instance, then your database instance. That is the sequence.
Okay. Thank you, Gaurav. I believe that actually helps. Yes, guys, there are some questions where people are asking whether we can share this. Yes, we are going to share the PPT. We are also recording the session, so that also access would be provided. Okay, Devajiti has a question. He is asking whether the database course means the CPU course of the server.
Yes, sir, can you repeat it again?
Yeah, it is asking whether you mentioned the database course, whether it means the CPU
Yeah.
course of the server.
Yeah, CPU course on the server.
Great. Okay,
So
there is one more interesting. Yeah.
there are two different cores, right? If we discuss in Exadata, so there are cores which are available on database servers and there are cores which are available on storage servers. So there are two different servers and two different, they are having their own number of cores. So when I'm talking about cores in database servers, it's actually it's actually the configuration of server. And in Exadata, we generally call database server as a compute node and your storage server as a cell node. So you might hear this term interchangeably. Go ahead, Arun.
Thanks. Okay, so Sonali wants to know whether you can quickly brief on IORM. I believe would that be one of the topics that you would cover in any of these next sessions that you are going to take?
No, that is actually planned in the last. If you see the session 3, where I will be talking only about the key features. If you see the last, the fourth is the IORM. Over there, I'm going to go in detail about IORM and its smartphone.
Great.
There is actually
Okay.
one question from. So there is, I
Yeah.
think, few questions. Free band will handle all cache using like private interconnect and iOS between storage and database servers for all. Yeah, Pranit, it's true that in free band switch will be able to handle the cache fusion as well as the data transfer between the storage server and database server. So the same in free band will be used for all these conversions.
Okay. And also, Chetan wants to know whether the term anti-index that you used, whether it is also used by Oracle officially, or is it something that you use to explain?
Oracle does not use it officially, but anti-index. But I have heard many people saying that if you are having Exadata, sorry, if you are having Exadata, you can drop your indexes. You must have heard these things regularly. So that is not the suggested way. And I would explain why I called it anti-index. I will call it. I will discuss it in my session 3. Why I called it anti-index.
Thanks, Gaurav. This is Chetan and Arun for thanks for covering that. And Gaurav, I must say beyond that you did really great job within the limited time. Big thank you.
Thanks,
Thanks,
Chetan.
Chetan. Yeah. So Gaurav, we will take one last question, and the remaining question, if you can quickly send it over here, I believe we can communicate over a mail. So Praveen
Yeah.
wants to know that how exactly the data is stored in the storage cache as compared to keep mode in database. How to keep the frequently used data in the storage server.
Okay. So uh, that will in detail I will explain in session 2 because before that I will be talking in detail about Exadata architecture and how it actually stores. But to summarize the answer, in summary, if I answer it, so it is actually in Exadata we generally right now we have two different configurations. If you remember, I discussed about the storage. We have high capacity and one is extreme flash. So in extreme flash, everything is on flash, whether your data files or everything is on flash. In case of high capacity, we generally create our data files on disk, but you have the option of creating those data files on flash as well, but that is not recommended way of doing. So in if I talk about the high capacity machine, your data files and your data will be there in the disk, but due to the smart scan feature, sorry, smart flash cache feature, whatever is the highly or hot data, highly utilized data, that Oracle, and if you remember I mentioned cell SRV process that automatically keeps that hot data in flash. That means when you are selecting a data or doing some operation on a data, it first goes and search in a buffer cache. If it does not find the data there in your memory in the database server, it goes and finds it in the flash. And if it does not find in flash, then only it goes to the disk. That means it is having most of the time, if you see the amount of flash the Exadata is having, there is a high chance that you will get the data in flash itself. But if you say that where should I store the data in high capacity, it will be on disk, and in extreme flash, it will be on flash.
Great. Okay, thanks Gaurav. Thanks for all of those answers. I see a few more questions coming in. I'll just pass it on over a mail, and I believe we can take those questions offline. And I'll just pass it on to
Yes.
Sumit for closure. Thanks, Gaurav. Once again. Over to you, Sumit.
Uh, Thanks, Gaurav and Arun. Uh, like on behalf of everyone here from All India Oracle User Group Bangalore chapter, I would like to thank everyone to respond and actively attending the session uh, on a very short duration and on a very little resource. We tried to manage it, and we did have some hiccups which we did not really anticipate, because we kept on testing as much we could do. Uh, but I would like all the members who are present here on this webinar, and few people I'm still seeing they are our YouTube channel. Uh, Please do send your feedback. We'll try to work on that. When we say we, it includes you guys as well, because you are part of this community. Being a non-profitable organization, it's all been driven by you guys. Uh, on front of the questions, please do send a question. Email ID is aiouz.blr@gmail.com. You can check those information also on our Facebook pages. Uh, like we'll try to answer over the emails or in the next call as well. So that is all I have. one request before we close this session for the day. I would like you to, help us promote this learning journey over the Facebook, because that is a very handy and very easy mode of reaching throughout. A few of the people are also attending this session from outside Bangalore, so that I see a very good sign. Because of course, being Bangalorean, it's not limited, uh, you know, to be for the Bangalore users only. So that's all I have. Thank you very much. Please do post your comments on our Facebook page. If something we need to improve on, we'll improve on that. And I would like to welcome everyone to join this group and contribute. Like I'll talk about Gaurav for a few seconds. He also attended one of the session when we started our very first uh, tech day, and from there on he has taken up one tech day, one webinar, this one, and continuing for the next two session as well. uh, so as Gaurav was showing, coming up as part of the same webinar, we have two sessions lined up, the part 2 and the part 3. Second part will be on 20th, the third one will be on 5th of January. uh, we also have 19th, on 19th December, a tech day event where you guys can, face to face question, present, whatever you want. So we are also preparing on that, and we organize our tech day at Strides IT, which is in Jayanagar, and mailers and all those information will follow very shortly. Thank you again. See you guys on both 19th and 20th of December this year. That's it from All India Oracle User Group from the Bangalore chapter. See you guys next session.
The last few lines were not heard probably by me or everyone, I don't know, but thank you as well. Take care.
Okay,
This is
thanks.
Chetan.
Yeah, thanks, Chetan.
After the session. Okay, so my name is Gaurav. I was just